Hello, students. Now we'll actually start a new unit, Systems of Quadratic and Linear Functions. This is the fourth level that you have to learn today. This gives you a good introduction for the process. It's really simple. Okay, so first in that fourth level, you have this graph that is presented to you. You're asked to find the equations of each linear each function, the linear. So if you have to first start out with finding the equation of the linear function. So the linear function here, mm, just a second. Okay, so the linear function would be the if you see the slope is 1. I don't have a grid here, but in the actual foldable, the slope is 1 and y-intercept is 3. So the first function, the linear function, it is y equals x plus 3. So to find the quadratic function from this particular graph, all you need to do is make a t-chart. So of the quadratic, you'll see several points here, negative 3, 0, the y-intercept, the other x-intercept, and 5, comma 8. You have 4 points. We just need 3 points to use regression. So we have 4 points. So negative 3, 0, 5 and 8, and 0, negative 12, and 4, 0. Put in the calculator with stat, edit, and edit, and then stat. Then you go to calc, quadratic, and you don't have to store equation, just calculate. And after all of that, you will see that the value you get would be x squared minus x minus 12, if I'm not wrong. uh, so you'll get these two equations. So the point here is that when you're asking to solve a system, you have to solve or find the points where they're actually intersecting. So I know from this graph you can actually see that these 2 points are intersecting. These two graphs are intersecting at these 2 points. But what if it is this kind of scenario? How many solutions would you have? Zero, right? They're not touching each other. Suppose I have a graph where it just touches the quadratic. Then and how many points is it touching? 1 point. So the solution will be 1. So these are the other two scenarios. Okay. So so that's the deal. And so now to find by hand these 2 points, this point and that point, what you need to do is you have to equate these two equations, this guy and this guy. Okay, by substitution you're setting them to each other. So you are substituting this x value, this y value, into this y value. Okay, so x squared minus x minus 12. So be careful, be watchful about the sign on x squared. If the sign is positive, then set this up in a way that the quadratic is on the left side. So if I'm just writing it out for clarity, if x squared term is positive, then quadratic should be on the left side. Okay, so that makes it positive. The x squared term must be positive. That's the whole point. So you'll see why I'm explicitly telling that. So for now, we'll just subtract the negative x, so subtract the x, subtract the 3, just so I can bring everything to the left side. So this becomes x squared minus 2x minus 15 equal to 0. So once you get this, you have to solve for x using the good old x method, right? If you can solve by factoring, that's well and good. So 15 is 5 times 3, and here the negative is on 5. So that when you add, you get negative 2. So we have x minus 5 times x plus 3. And when you equate each of them to 0, x is positive 5, and from here x is negative 3. So we are not done here. So that's the catch. The only additional step that you're doing is I'm trying to scroll this up. The only additional step is to find the corresponding y value. What is the y value for this x value? What is the y value for this x value? So what you need to do is, for x equal to 5, you're plugging in this x equal to 5 in either the linear function or the quadratic function. You're going back and substituting them there. So it's easier to substitute in the linear function, which is y equals x plus 3. So you're substituting the x value of 5 here. So y equals 5 plus 3, which is an 8. So we have 1.5 comma 8, right? And for x equal to negative 3, y is, we are substituting again over here, negative 3 plus 3 is 0. So negative 3 comma 0 is the other point. So this is how we find the two coordinates. So your answers must be in the form of coordinates. See, we got the same 5 comma 8 and negative 3 comma 0 from the graph also, right? So that's the concept behind this. Once you get the concept, I'm telling you, this is really easy to understand. Okay, so we'll go to the next example. The next example, he has directly given you y equals, he has found the equations for us. So all you have to do is just set them to each other. So first of all, y equals 2x plus 2, and the other one is y equals negative x squared plus 5. Now if you see, the x squared term is negative. When the x squared term is negative, put it on the right side of the equation, just so that when you actually put them all together on the left side, the x squared term will be positive. So now solve by adding x squared on both sides, subtracting 5 on both sides, because we want the quadratic on the left side of the equation. And do the x method solving. Okay, so um, so we need 3 times 1 is 3, but 3 minus 1 is a 2. So we have x plus 3 times x minus 1, and x is negative 3 and positive 1. Um, so for each x value, you must find the y value. Y equals 2 times negative 3 plus 2, which is a negative 4. So the first point is negative 3, negative 4. For x is equal to 1, y equals 2 times 1 plus 2, which is a positive 4. So the other point is 1 comma 4. Okay, that's how you do this. So try the third one. It turns out that the third, which is the example 2 problem, I'll set that up for you, and you can solve it with the quadratic formula. Okay, so let's look at how that works. I'll just set it up. Let's take orange this time. Let's see how that works. So we have 4x equals 2y plus 4, and negative 5 equals negative y plus, sorry, minus x squared. So none of these are set as y equals. So we need to do that. We need to do some pre-work. So if you look at the first equation, 4x equals 2y plus 4, you need to subtract the 4 and bring the y. So you can write it as 2y equals 4x minus 4, right? So if you divide by 2 on both sides, you'll have y equals 2x minus 2. And the other one is negative 5 equals negative y minus x squared. So if I add y, it's y minus 5 equals negative x squared, and add 5 to push it to the other side. Okay, again the x squared is negative here, so when we have x squared as negative, we write it on the right side of the equation. Okay, now add the x squared and subtract the 5. So you'll get x squared plus 2x minus 7 equals 0. As you see, 7 cannot have factors, so the only go here is to use the quadratic formula. So we'll use the quadratic formula. The quadratic formula is negative b plus or minus square root of b squared minus 4ac all over 2a. So this becomes negative 2 plus or minus square root of 32. By the way, square root of 32 means it is square root of 2 times 16, isn't it? And 16 is a perfect square, comes out as 4 and 2 remains inside. So x becomes negative 2 plus or minus 4 root 2 all over 2a. So 2 goes everywhere. So if you can reduce this, this becomes negative 1 plus or minus 2 root 2. But Miss Madhuri, how would we find y values for the corresponding x values? Okay, this means that this is negative 1 plus 2 root 2 or negative 1 minus 2 root 2, isn't it? So just plug it in just like that. So we will plug it in the linear function. So this is y equals 2x minus 2. So 2 times negative 1 plus or minus 2 root 2 minus 2. So distribute the 2, negative 2 plus or minus 4 root 2 minus 2. So y equals negative 4 plus or minus 4 root. So go by plus to plus, minus to minus. So the points would be negative 1 plus 2 root 2, comma negative 4 plus 4 root 2. And the other point would be with the minus, negative 4 minus 4 root 2. And that's it. So I want you to focus more on problems like the first and second. And then you have a quizzes to do. The practice sheet is, you probably took it already. So I want you to practice the quizzes questions, and we will catch up with what you have learned in the next class during the warm-up time. All right. So I'll see you in the class next time. Thank you for watching. Bye-bye.